Hey everyone, good evening. This is Lambda School's Introduction to Web Development Night 4. My name is Deandra Ryan Moss. I'm your instructor, and right now I'm really hoping that I am not on mute, because that's happened the last two nights. But anyways, welcome to Night 4. So this is we're pretty much halfway through at this point. And yay, I'm not on mute. So we're pretty much halfway through. So there'll be 4 lessons this week and then 4 more next week. So and I would say maybe the worst of it is over, or maybe the worst of it is to come. We'll find out. But anyways, this week we've talked about a lot of different topics. I introduced you to the 3 languages that are really the crux of front-end web development: HTML, CSS, and JavaScript. And from here on out, we'll be focusing primarily on JavaScript. So, excuse me. So more on that today. Yesterday, I introduced you to tons of things in JavaScript. I know that yesterday's lesson was kind of a trial by force. We just threw a ton of different topics at you. And tonight is the start of us going into a little more detail on some of those topics. So I'm going to start off with a little review of a few things we covered, and then we'll spend the rest of the night talking about different topics in control flow. So more if-else statements and some looping at the end. Before I get into all that, I want to talk to you a little bit about Lambda School's main curriculum. As you guys already know, Lambda School is an entirely online computer science and web development immersive. Over the course of 6 months, we will teach you everything you need to know to get hired in the world of web development. And while it is a full-time 6-month course, we do also offer a part-time course that only runs twice a year. So that is part-time in the evenings. If you're curious about that one, you might have to check the website or reach out to Karen for the exact start date of the next part-time course. And speaking of Karen, for any of you guys who are interested in getting the admissions process rolling on Lambda School, she is the go-to person. So please ask any questions you have or reach out to her if you're ready to start that process. Tonight, I wanted to take a deeper look into what day-to-day life looks like at Lambda School. So our goal is in this introduction course to mimic that Lambda environment as best as we can. There are some limitations since this is only 3 hours versus an entire day, but we try to kind of give you a taste of what you would get in Lambda School. So we do use Zoom for starters. That's already a tool you'll be familiar with. We use Zoom for lectures, and we also use Zoom to put you guys in groups and do group work, which you have a little taste of as well. Beyond lectures and group work, there's definitely homework. There are projects. That's something that I think is pretty cool about the main curriculum as opposed to this intro course, is that because we have a little more time, we're able to do more, excuse me, we're able to do more expensive projects. And then, so there's project work, there's more Q&As, more opportunity to go over the homework and things like that. So a lot of what you're used to already, but just more of that. And it's really a dynamic setup we have. So we don't want you to be doing any homework or anything like that outside of the allotted 8 hours we have for Lambda School. So there's time for solo work, there's time for group work and lectures, Q&As, things like that. So that's a little look into life at Lambda School. As a reminder, it is a full-time Monday through Friday work hour type schedule. And one thing I do want to mention as well is that we advertise it as 6 months. It's 6 months of actual active Lambda School, but because there are breaks throughout that, it ends up being a little longer than that, depending on what time you start. If you attend a portion that includes, for example, Christmas and the New Year, it will be a little bit longer for you to complete that. So it will take you slightly more than 6 months because of breaks. For the exact timing on that, Karen would be a great person to reach out to. So there's a little more insight into what life at Lambda School looks like. But let's not get too ahead of ourselves. We still have a bit of JavaScript to do today. So let me jump in on that. As mentioned, today is all about control flow, which is a topic I briefly introduced last night. So I'm going to open the floor up to you guys. Who can tell me what control flow is? All right, everybody go. Throw a million answers at me. And you guys have been pretty on point with these answers so far. So I'm excited to see what you come up with for control flow. Everyone's gone quiet. All right, apparently I haven't defined control flow very well because not everyone seems to know this one as well as some of my other questions. Okay, I see a few good answers. So we have flow of the data, stuff about conditions, decisions, if statements. All right, so these are, you're getting in the right direction, but apparently my first order of business is to define control flow, because I guess I didn't do a good enough job of that last night, or I defined it at the end of teaching you guys a billion other things. So, oh, I see a really good answer, which is order in which lines are processed, which take precedent. So that's close. So yeah, control flow is all about the order that the code is run in. So this could mean, as we saw already last night, choices, such as maybe the code sometimes goes this way or sometimes goes that way. But control flow can refer to more than that. For example, we're going to see tonight with looping, which is that sometimes control flow dictates that one line of code should be run multiple times. So it deals with what lines of code run, in what order, and how many times they run. So a nice way to sum that up is just figuring out what lines of code are executed and in what order. So yeah, let's do a little deeper dive into if-else statements, and then I will show you guys loops. Let me share my screen so we can get started on that. All right, I have Replit pulled up here as a little reminder. Replit is the sandbox environment we will be using for the rest of this course. It's a really great, easy way to just run little chunks of JavaScript, and it has this nifty feature where it will show us what our last line of code resolves to. So using Replit, let's do a little review from last night. And actually, let me pull my Q&A up here so I can see you guys. See what you guys are asking. And I already see a request to spend a little more time going over what the homework should look like tonight. So I can't promise that. Depends on how long the lecture runs, but I will make an effort to try and spend a little more time talking about the homework before I set you loose with it. But good request. Okay, so review in JavaScript. Let's go ahead and start with types. So I introduced you guys to the primitive types last night, as well as briefly mentioning functions, which are a non-primitive type. So let's start with the primitive types though. So we have different things we can create in JavaScript, different objects. We could create a number. We could create a string. We could create a Boolean, such as true or false. And we could also create undefined or null. So let's talk about all of these. So numbers, there's just one example. Refer to any number. It could be a whole number, a decimal, a negative. It could be the square root of 2. It could be pi. Those are all numbers in JavaScript. And the way we create those generally is by just typing out the number, like so. And those are great for everything math related. And as we saw, there's lots of nifty math operations that are built into JavaScript, whether our basic arithmetic or more complex things that we can do using the math global object. The next thing I taught you guys were strings. So strings are a chunk of text. They can be little phrases like this. They could be utter nonsense. We could even type out a number in string form. So this refers to a chunk of text containing these numbers. So we would think of this as text, not as the number itself. So those are strings. They're extremely commonly used, and they have a bunch of nifty methods built into them. We only explored one of those yesterday, and you don't need to know many string methods for this course, but they are all documented if you're curious about more fun things we can do with strings. The next two data types, which we will, or the next two examples of one data type, which we will talk about a ton tonight, are Booleans. There are only two possible Booleans, true and false. And you would create them by typing out the keyword true or the keyword false. We're going to talk a lot about these tonight because they are pretty critical to if-else statements, because we have conditions in if-else statements. So those are Booleans for you. The last two, which are kind of oddballs, are undefined and null. There are two different ways of referring to missing data. And we would create those by typing out either the keyword undefined or the keyword null. Keep in mind that these are two totally different data types, though they work in similar ways. So there you go. Those are the 5 primitive data types that I taught you last night. Of course, it's not very interesting to create data unless we store it. So I also showed you guys how to declare variables. So if you wanted to store a user's name, for example, you could, or some sort of input text that you received from the user, that might come in a string form, and you could always save that into a variable. If this were actually input text, we might save it under input. So this string is being stored in memory, and we've signified that input is the variable name, which means that that's how we will look up this data in the future. So when we type input down here, we'll be able to retrieve the string that input points at. I use the keyword const to keep track of this because constant variables are a nice kind of default to start with. Constant variables just mean that we can never assign a different value to this variable name. If there were different input later, we couldn't reassign it using the same variable name. That is restricted if we use const. However, if we wanted to do something like this, we could always use let. Let is a different keyword for keeping track of variables, the only difference being that it is reassignable. So if we wanted to use that same variable name input to refer to different users' input, those would be changing, so we'd have to use the keyword let. The last word we might use to declare variables is var. I discourage the use of var because it is outdated and you really don't need it. Stick with let and const. It will force you to be a better developer. And as promised last night, I will talk in just a minute about one of the differences between var and let, but we're not there quite yet. Let me do a little more reviewing first. So that's the essence of variable declaration. Just make sure you have your keyword, the name of your variable, a single equal sign, which always refers to assignment in JavaScript, and then whatever value you want to store inside. And if you're ever reassigning or looking up values, you never need to use this keyword again. This variable declaration keyword is only necessary the first time you declare it. If you're looking it up or reassigning, that keyword is no longer necessary, such as in line 4. So there you go. There's a little summary of declaring variables. This is something we will use every single day for the rest of this intro course, and probably every single day that you use JavaScript, because it is the foundation. It's hard to do much of anything unless you're actually storing data. So there are a couple more things I wanted to review that will come up tonight. The first one is this weird plus plus minus minus operator I showed you last night. So as a reminder, if you had, for example, an age variable and you wanted to increment it, you could always reassign it to whatever value is 1 more. But there is a shortcut to doing that. You could also, actually, let me show you a couple different ways to do this. You could also do age equals age plus 1. So what I'm saying is take the old value of age, add 1, and store it back into age. So that would totally work. There's a shortcut to doing this as well, but I will let you guys Google that if you want. But the shortcut that we love is plus plus. So this is something that we will definitely use when we get to looping. This is just a shorthand way of saying I want to, let me actually put that line back, sorry. So this line 4 and line 5 literally say the same thing. This is just a shorthand way of doing it. So up here, we're saying, okay, take the old value of age, add 1, and store that value back into the age variable. Because this is such a common thing that we would want to do many times in our code, perhaps, we have a shortcut for doing it. It's just the plus plus operator. So what we've done is we've incremented age once on line 4 and a second time on line 5. So now the value is all the way up to 17. If we wanted to go backwards, we could do that as well. So line 4 and 5 still say the same thing. This minus minus operator just says, hey, take the old value of age, subtract it by 1, and then store it back into this variable. So I'll go over those again briefly when we get to loops at the end, but I wanted to remind you of those to get you ready for what's coming tonight. The last thing I want to review is if-else statements. So we will be seeing a lot of these tonight. So the idea with an if-else statement is you have some sort of condition. If the condition is met, you run one chunk of code. If the condition, oh, that doesn't belong there. If the condition is not met, then you run another chunk of code. For example, if we had if it is summer, by the way, a little note for you guys. Notice that when I used sorry, an apostrophe, yes, that's what those are called, sorry, that it signified, the code interpreted this as my string is ending. So you can do something called escaping. By adding a slash before the symbol, I'm saying I want this as the character of the apostrophe, not a signal that I'm closing the string. So if you guys have tried to put quotes or a single quote into your strings and found an issue with it trying to close itself out, the escape character will help. So it's a little confusing in Replit because, well, if you log to the console, you can see that the slash doesn't come through. The slash is not actually part of the string. It's just my way of cueing that this is a single quote, not a closing of the string. So you don't need to know that, but it's a useful thing to know. And totally unrelated to if-else statements. All right, so we might have two different log statements depending on if it's summer. If it's summer, we know that school is out for summer break. If it's not summer, we can probably assume that school is in. So this would be the case where we might want to use a conditional. So we're saying that sometimes we want to run line 5 and sometimes we want to run line 7. And it all depends on, let me put the variable that actually belongs there, and it all depends on if it's summer or not. So we have our keyword if, followed by the condition, followed by what's called the if block. And the if block will run if the condition is true. Then we have that block closed out with this curly bracket. We use the else keyword to start the else block. And this is also an optional chunk of code that will only run if this is set to false. So if I change this to false, we see that the behavior of our if-else statement changes. Oh, and okay, there we go. All right, so that's a little review of an if-else statement. If you're not feeling totally comfortable with them right now, that's fine, because we are going to spend at least the next 20 minutes talking about different things we can do with them. So cool, let's jump into it. The first thing I want to talk to you guys about is something called scope. And I will warn you right now that scope, I think, is one of the most sophisticated topics that we're going to cover in this class. So I'm going to introduce it to you guys tonight. It's going to come up a lot. It's going to come up almost every other night. And I'll show you more examples of it. So if you don't feel totally confident about scope right now, that's fine. I just want to start you guys thinking about scope. So let's do a simple little if statement. I'm going to go ahead and hard code it to true so we know it will always run. And let me talk about different scopes. So the scope is kind of like the environment. Think about, there are different worlds we exist in depending on where we are in the code. The default scope is called the global scope. We're always in the global scope. So no matter where we type our code, we're in the global scope. So just any regular old statement out here is going to be declared globally. Think about how I introduced this idea of global objects like math. That's because math exists everywhere. So the global scope is like, if we're in a fishbowl, it's the water. It's everywhere. So if I declare a variable, that exists globally. I've declared this variable out in the global scope, which means it can be used anywhere you want. So notice that if I try to console log X down here, it works. If I try to console log X in here, it's gonna work. If I try to console log X down below my statement, it works. So anywhere I wanna access X, whether it's to console log or to do something else with it, it's allowed. I got all 3 console logs. So when we create an if block or an else block, we create a new scope. So we have just created a more specific scope. Rule of thumb, whenever you see a pair of these curly brackets, we've probably created a new scope. So even though X was declared in the global scope, we still have access to it within the if scope. So think of these as nested scopes. Because the if scope is a almost subscope of the global scope, we can still use X inside of here. That's totally legal. But the same is not true if I create a Y inside of here. So we really care about where was a variable declared. X was declared globally, so it's globally available. Y was not declared globally. Y was declared within the if block, so it's not available globally. If we want, we can use Y as long as we're within that scope. So this works. I was able to console log Y. But if I try to console log Y after the scope is finished, we're going to get an error. Y is not defined. So in short, anything that's declared inside of an if block only exists inside of the if block. It's like a dream. Once you're in a dream, you'll probably forget whatever happened by the time you wake up. But in a dream, you can generally remember everything from the waking world within it. I don't know if that's a good metaphor or not. I was trying that one out for the first time. But that's the gist of scopes. And this ties into what I told you about the var keyword. So if we use var, now it's available globally. So it turns out that the scope thing, while maybe annoying at first, and it's still exists only in the scope if I use let as well. So the scope thing might seem like an annoying frustration at the beginning. You already have so many other things to worry about, but it's actually a good thing. This is one of those things that forces you to be a good developer. If you want to use something globally, you should declare it globally. You should not be declaring things inside of an if block and using them elsewhere. That's why it's designed this way. And that's another reason why you should use let instead of var. And I see a question that says if this is true for function or for variables in a function. Yes, it is. And we will talk about that Monday. So whenever you create a new scope with these curly brackets, the same thing is going to be true. It's also true inside of an else statement. It's also going to be true inside of a loop, which we will explore at the end of class. So once again, scope, not something you need to understand in detail right now, but the big takeaways for you guys is just if you ever declare a variable inside of your if or else blocks, that variable can be used until the end of the bracket. Once the bracket is done, we're out of the scope and your variable is going to disappear. So that's scope for you. We'll be talking about that in a bunch more contexts as we move on throughout different lectures next week. So there's my little scope lecture. Okay, now let's totally switch gears and talk about comparison. So I introduced you to some comparison last night. We're going to explore that more tonight. So let me throw together a super boring if-else statement. All right. So I'm going to set age to 19. So I am from Utah, and as it were, the smoking age in Utah is 19. Fun fact. We're going to use that fun fact for a little comparison operator lecture. So we know that if age is less than 19, we can console log no smoking in Utah. Else, smoking in Utah is a-okay. Except maybe not because like lung cancer, but we won't get into that. Okay, so here's a little if-else statement with a comparison. So we've seen how we can put Booleans directly in here. We can actually literally hard code a Boolean in if we want. not very interesting because it's going to do the same thing every time. We can also, if we had a variable set equal to a Boolean, we could drop that Boolean in. As a reminder, that's because we don't care what this variable is called, we just care what it resolves to. Because bool resolves to true, we can use it anywhere we would use true. The same works with the comparison operator. Because this comparison, if age is less than 19, resolves to true, then we can use it anywhere we would use true, or actually in this case it resolves to false. But it's going to resolve to a Boolean regardless. So now we can go ahead and run this and see that this still works. And if age were something that we're dynamically changing based on our user, and if we wanted to, we could also say if age is less than or equal to 18. And there's also greater than or equal to's. So that's a cool thing, which is that we can throw a comparison into this if statement. And remember, a comparison is just resolves to a Boolean. So it can be used like a Boolean could be in any case. So let me show you one other comparison operator. I'm going to stop coming up with clever examples and just hard code this in. So actually all right, this is going to be kind of a lame but good learning tool if else statement. So it'll just console log if the if runs, it'll console log else if the else runs. So another thing we could do is check, we'll keep that as age. If we were looking for a specific age, we could always compare using the triple equal sign. So new developers are always tempted to do this, right? This seems totally intuitive. If age is equal to 16, what happens here? We got syntax error, assignment to a constant variable. That's because the single equal sign is reassignment. So it's interpreting this line as saying reassign age to 16. That you're not allowed to do that. Even though it's the same value it had before, you're never allowed to reassign that. So that's not even close to what we're trying to do here. So make sure you use the triple equal sign if you're ever trying to compare two values. Now it's going to check, does the resolution of age, which is the number 16, equal 16, which yes, of course it does. If I change this to 15, we would get our else statement. There is also something called the double equal sign. This one's a little weird. For example, the string 16 would be considered the same as the number 16. The short answer with the double equal sign is that it doesn't care about type. So just stay away from the double equals for right now. The triple equals is a good place to start. Once you have the hang of that, you can look more into the double equals, but using the double equals is a good recipe for bugs at the beginning. So it can be super useful though once you have the hang of JavaScript a little more. So stick with the triple equals for comparison. Definitely don't use the single equals. It's never used for comparison. Similarly, we can check if something is not equal. Remember our not operator, the exclamation point? If we just throw that in front of the triple equals, so not equal equal, now we can check if these are not equal. So now the logic is getting a little hairy. Let me change this to a number. So 10 is not equal to 16. It is true that 10 does not equal 16. So our if statement ran. If I put 16 here, it is false. This is like a double negative. It is false that 16 is not equal to 16. So it's kind of better to just use a equal sign instead of a not equals in most cases because you end up with confusing double negative stuff. But there are going to be some cases where this not equals operator becomes super useful. So it's good to know that one. So those are the big comparison operators. We have less than, greater than, less than equal, greater than equal, triple equals, double equals, which you guys want to avoid for now, and not equals to. So these are all pretty cool because we're now, instead of just putting a Boolean straight in here, we have some logic here. Things got a little more interesting. So instead of just throwing a Boolean straight in, we're actually comparing things, and a comparison resolves to a Boolean. So it works out. All right, so there's a little spiel on comparing. The next thing I want to talk to you about is totally weird, and it's called truthiness. Yes, you heard that right. Truthiness and falsiness. So, falsy. So far, unless you guys were feeling exploratory in your homework tonight, we've only put conditions into our if-else statement, or a Boolean into our if-else statements as our condition. So I don't know why I deleted this. I'm just going to retype it. Okay, so we've played with putting Booleans or things that resolve to Booleans in here. So if any of you guys were feeling adventurous on the homework last night, you might have tried putting a non-Boolean in. So let's say we put in a string. You might expect that by putting a string in as a condition, you would get an error. That seems sensible, right? Wrong. JavaScript is weird. So it turns out you can put whatever you want in this condition. By default, you would think of this as being a Boolean, but you can literally put anything into that condition. So the question remains, how does it know which one to run, the if or the else, if it's not a Boolean? Well, it turns out that every single thing in JavaScript is truthy or falsy. So we know that true, the Boolean, is true, and false is false. But every other possible JavaScript object you could come up with has kind of a Boolean analog. It's sort of like retrofitted to become a Boolean when it's thrown in a condition, like as a condition, like in an if statement. So I'm going to teach you the rules for figuring out what is considered truthy and what is considered falsy. So we're going to go through all the non-Booleans and talk about if they're truthy or falsy. So just from this example, we saw that the string I put in triggered the if statement. That means that it's truthy. If I type out the string, truthy. If I type out the string false, still truthy. So you might be thinking, okay, all strings are truthy. That's almost correct. All strings except the empty string. If we put the empty string in, that is actually going to be considered falsy. So how about numbers? It's going to be very similar. So almost every number, positive, negative, negative decimal, are all considered truthy. So all numbers except 0. Turns out that 0 is considered falsy. Once again, falsy means that if it's treated as a condition, it will trigger the else statement. It will be treated as if it is a false. So the last two I want to show you are undefined and null. Turns out that both undefined and null are falsy. So you might be noticing a pattern in these falsy. So by default, most things in JavaScript are going to be considered truthy. It turns out that the falsy values are things that in some way signify missing data. Of course, null and undefined signify missing data. That's what they're for. But the empty string also kind of implies that something is missing, and 0 is a lack of a number. So all 4 of these are considered falsy. I remember when I first learned this, I thought it was totally absurd. In general, I was pretty indignant about JavaScript when I first learned it because I came from Java where things are very strict. And in JavaScript, there's lots of wiggle room, this being a prime example of that. But it turns out that I use this all the time now. For example, let's say I was checking if a user had an address, or I was checking, doing some sort of error check to make sure that my user had entered in an address. If the address were missing, I might want to trigger an error message. So what I could do is say, if there is no address, so notice that because I'm nodding it, if this is falsy, it will turn to true. So if the address is missing, I might console log error, missing address. As a note, this is not the correct way to throw an error in JavaScript, but that's okay for right now. So now if the address is an empty string, or if it's null, or if it's undefined, in all these cases, I would be able to use this line of code to say, hey, the address is missing. So that's the most common situation where I use the truthy falsy thing. There are other cases it might crop up. Speaking of this not operator, another fun thing to note is that if you not, as you might have guessed from that, if you not a string, it's going to turn, because strings are truthy, it'll turn false. If you knotted the empty string, it would turn true. So it's just reversing. Anything that we knot from the falsy list will turn true. Anything we knot from the truthy list will turn false. And if we ever wanted to turn a truthy value into just true, or a falsy value into false, we could do the double knot. So this will turn an empty string into false. It will turn a 0 into false. It will turn any other number into true, any other string. You get the gist. So you'll see a little bit of this double knot thing on the homework tonight. That's just a way of turning a truthy value into the Boolean value true. So this went from truthy to true. So there's the double knot for you. There's really not much of a point of doing a double knot with a Boolean because it'll just turn true into itself. So, all right, so that's truthy and falsiness. Another interesting technique you can use with your if-else statements. All right, the next if-else related topic I want to cover is logical operators. I love logical operators because I am a giant math nerd. But you may not love logical operators. In fact, many people find them rather difficult. And that's why we're actually going to have you spend a lot of time on them in the homework tonight, because there's something that you just kind of, if you don't have a knack for it, you just kind of have to drill them and then they'll stick. And trust me, if you get them down at the beginning, you'll save a lot of time in the future trying to figure out what your if-else statements are supposed to be resolving to. So what are logical operators? They are ways of combining Booleans. So comparison operators, like less than or equal to, we might compare to numbers, or we might compare to strings, or we might compare to something else's. But what if we want to compare, or not compare, but combine Booleans? So basically, we're taking logic and making more logic out of it. So there are a few different ways to combine Booleans with each other. And the first one I've actually already showed you, which is not. Not is definitely the simplest logical operator. We're not even really combining anything. We're just changing a Boolean. So we know that the not operator turns true to false and turns false to true. So I'll put that up here. Not. True becomes false, and trying to figure out a good way to write this down so it makes sense to you. Okay, so the not operator, true turns into false, false turns into true. That one's pretty easy to get down. The next one I'm going to show you is called and. And you create an and using 2 ampersands. So true and true becomes true. So this is actually one of those ways of combining Booleans. So you could combine 2 Booleans, and if they're both true, the result will be true. If at least one of them is false, then the result becomes false. So we have, if we had true and false, or false and true, that would become false. If we had, these dashes are getting out of control. False and false, that becomes false. So this might be seeming extremely abstract right now. So let's take a look at an example. We talked a little bit before of this idea of like trying to figure out if school is in or not. So actually, no, that's a good example for or. Let me come up with a good and example. So let's say that, oh, I know, I had the pleasure of going to the DMV this week, which is always fun. especially when you live 45 minutes away from the DMV, because then you have to like painstakingly make sure you have all the ridiculous things they want you to bring with you. It turned out that to get my Arizona driver's license, I needed two things. I needed my old Texas license, which I brought, and I needed my passport, which I also brought. So you might say, if you have your Texas license, I'm assuming they would have taken license from other states too, and passport, we'll just turn this to old license. So I had my old license and my passport. So then I can you get an AZ license. Cool. So both of these are required. So up here, this looks a little abstract, but down here, maybe this is making more sense with a real world example. So because I brought both of these, I was able to get my Arizona license. So you use the AND operator when you have two or more conditions that are required. You could throw more things in here. I also had my paperwork and my fee, all things that were required. So think of AND as being all conditions are required. So if either of these were missing, if I forgot my old license, I wouldn't have been able to get my new license. Or if I had forgotten my passport, also wouldn't have worked if statement does not run. And finally, if I had forgotten both, definitely wouldn't have worked. So think about an AND operator as something you would use if you have two or more conditions. If you have two or more conditions, all of which need to be met. Every single condition is required. Yeah. So, and I just had I'm going to actually answer this question right now, which is a question about doubling things. So Jim noticed that there's a theme of doubling coming up. We had the double equals for this. We had double ands for this. The reason is so that it's clear what you mean. So the single equal sign means assignment. So we have to come up with a new symbol for comparing. So we use the double and triple equals. The same is true with these. It turns out that the single and the single pipe, which we'll show you in a minute, are actually binary operators, which we will cover in the main curriculum, but don't cover in this course, which is too bad because binary is lots of fun. Once again, math nerd. You might not like binary. I like binary. So these symbols are already used for something else. So we just double it up as a way of us telling the code, hey, this means one thing. It's so we can use symbols and not run out of, basically it's so we don't have ambiguous code that the computer doesn't know how to interpret. So that was a little side tangent, but I thought that was an interesting question, so I just wanted to answer it. All right, so that is AND. Think of AND as everything is required. And it's similar to how the word and is used in the English language. I needed my old license and my passport. We wouldn't say I needed my old license or passport. Speaking of ORs, that is the next one I will show you. OR is represented using the double pipe. These are pipes, not L's. It won't work if you use L's. So true or true resolves to true. Oops, comment. True or false, in whichever order, resolves to true. And false or false becomes false. So once again, this is kind of the formal logic abstract-y way of thinking about it, but we'll talk about an example now. The short answer here is that you need one. You need at least one. You could have both. You could have this one. You could have that one. But if neither are fulfilled, you get a false. So let's talk about this school example. So if it is summer or Christmas, we know that school will be out. So you might say if summer or Christmas, school's on break. So you don't, it's actually, I don't know why it is summer and Christmas. Both are true. Maybe we're in Australia. Probably only one of those is going to be true at a time, unless you're in Australia. I think Christmas happens in summer in Australia. Okay, not related to coding at all. But if it's true that it's summer, then school is on break. If it's true that it's Christmas, school is on break. If it is false, then school is probably not on break. And we could keep ORing. We could come up with something like, you know, the second week in fall or whenever your fall break is, or Easter. I don't know. I went to Catholic school, so I think of Easter as being a time for a break. I don't know if the rest of the world does that. But yeah, so this is an example of an or. If both are false, then they're going to resolve to false. However, if at least one is true, then they resolve to true. And you can start to combine these in convoluted ways. I actually really like this DMV example because, of course, when I officially got my description of what I needed to bring, it was something to the effect of like passport or social security card, you know, or birth certificate. So I like needed one of these three, like, and driver's license or state ID. You know, those like bureaucracy is a really good place to use logical operators, I think is the takeaway of tonight's lesson. So this is a totally convoluted statement. You know, we're saying, okay, we need at least one of these and at least one of these. You won't have to do anything quite this wacky on the homework unless you do the stretch problem. I think I gave you a pretty crazy one. And you can always throw knots in here too if you want to make everything completely insane. So the takeaway here is that you can combine these ad nauseum, and that can be really useful for writing sophisticated code, especially if you're writing DMV software. But heaven forbid any of us end up writing DMV software someday. I shouldn't joke. I wrote government software when I was in the field. Yeah, so those are logical operators. Think about them as ways of combining logic together. And they're a nice way to create even more sophisticated if-else statements. So there's a summary of these. Don't fear I'm about to delete this, but you can easily Google a nice little logic table for ands and ors and nots. And another note is that even though the syntax might be slightly different, these logical operators are universal. All coding languages use them. They're common in math as well. So these are not just JavaScript specific ideas, though I've taught you some JavaScript specific syntax. So anyways, those are logical operators. Let's talk about else if statements now. So yes, else if, different than if else. You might have noticed that if else has a limitation, which is there's only two options. You have your if and your else, nothing else. Sometimes in life you want three options. Let's say that you're trying to, oh man, I need to come up with some good examples, not on the fly sometime. Let's say that you're trying to figure out if you're gonna get a dog or not. Okay, so you might say if, and you, man, I don't know if this is a good example. Sorry guys, it's getting to the end of the night. All right, let's come up with something really simple. So we're gonna do something where we figure out if a number is divisible by 3 or not. No, that uses the mod operator that, okay, I swear guys, I've taught this before. I know what I'm doing. Okay, so I'll just show you how it works and then I'll come up with an example while I'm typing this out, hopefully. Okay. This is the least creative example ever. All right, so we have 3 options here. So instead of 2 options, like you would have, oh, seasons, that's a good one. Thank you. I closed out the chat. I bet other people are throwing things into the chat and I'm totally ignoring it. Okay, seasons. So we'll do, yeah, that's a good example. So if We're going to say it's fall. I don't know why I'm saying it's fall since it's not fall right now. I think that's me wishing that fall would come sooner. Okay, so we might say if it is summer, then go to the pool. Else if it is winter, build a snowman. We'll throw another option in here. Else if it is spring, else we can probably assume that it is fall, and we'll console.log rake some leaves. Okay, so now we have actually 4 options, and it turns out that else if statements are great for 3 or more options. So here's an example with 4. So the first thing we do is we check, and notice that I didn't even use this fall variable here. So the first thing we do is check if it's summer. If it's summer, we go to the pool. If summer is true, we're done. We're straight up done. We never check anything else. So if I just set all these to true, if we're in like Bizarro world where somehow it's all seasons at once, we'd never get past this first condition. So once we hit at least one true one, we're done. But if summer were false, we'd move on to the next one and say, okay, winter is true, so build a snowman. And we never move on to the next one because this is true. But if that were false, then we'd move on to spring. And notice that if we don't even need this fall thing because we know that if it's not summer, winter, or spring, it must be fall. So we can just do a default. We could always end with another else if, but if we want a default, we can just use else. So this is a way of having multiple conditions. And I think the most important things to remember here is that we say else if followed by a second condition. And the other thing to remember is once a condition is met, we quit. We'll never see the rest of it. So there is a little example of the else if statement. You have a homework assignment tonight that will allow you to play with that with a little like, are you of legal age to do different things example. Okay, cool. So thank you for rescuing me with my total brain fog and inability to think of a good example for that. All right, so now we're on to looping. We're done with our conditionals and on to looping. So let me start by giving you a nice little what not to do example. These are my favorite. You'll see more of these. So let's say that you wanted to write a countdown, 3, 2, 1, 0. You could do some, actually, let's do a count up. So you just want to count to 3. So we'll start with 1, 2, and 3. And actually, I'm going to start with 0 because we like to start with 0 in computer science. Okay, so this is valid code, and it will do what we want, which is count from 0 up to 2. But this is not dry. So I'm introducing you to my favorite acronym now. DRY stands for don't repeat yourself. If you are copying and pasting things, sometimes that's okay. But that's a little clue that maybe you're not writing the most dry code. You want to, when you're starting to write things that are either the same over and over again or things that are very similar or have a pattern like this, you don't want to just hard code it all out. You want to come up with a better way of doing it. And in this case, a loop is probably the way to go. So let me show you a nice little loop. So this is the what not to do thing. Now let's do it the right way. So we'll do, let me type it out and then I will break it down for you in great detail. Okay, ta-da, that just did the same thing. We counted from 0 to 2. So what in the world happened here? Well, it's not so different from an if statement. This is a for loop. We start with the keyword for. Instead of one condition, we actually have 3 conditions in here. I will talk at length at what each of those means in a moment. So we have 3 conditions, and those will determine the behavior of the loop. Basically, they determine 2 things. They determine how long the loop loops for, and they determine the value of I. I is our index. It's our way of keeping track of where we are in our loop. So it turns out that this one is set to loop 3 times, and I will be equal to 0, 1, and 2 as we go through. So this, everything inside of the loop scope, and yes, this is another example of scope. For scope sounds like some weird dentistry piece of equipment or something like that. Anyways, you can tell it's the end of the week, right? We're all getting a little wacky here. So for scope, so we have new scope in here, and this I will be available to us as long as we are in our for loop. As you might have guessed, I is not available outside of our loop. That's because of scope. So don't try and use I outside of our loop. This is a good thing. We wouldn't want to have to come up with a new letter every single time we looped. So we can reuse I every time we have a loop, but the bad news is that I will disappear when we're done. But actually that's good news, so it's fine. But scope, another example of scope. So we use the for keyword whenever we want to start a loop. So we use the for keyword followed by 3 conditions, and those will determine how many times everything inside of the for scope is repeated. It will also change our index, our value of I as we go. So let's break these down in detail. Condition 1, starting value for I. Yep. Condition 2. Keep looping condition. And then condition 3 is change I. Okay, so here's how we think about it. We need a starting value for I. So condition 1 will only run 1 time at the very beginning. This declares I. Notice I used the let keyword. Let is critical for loops because I is going to be changing. I has to change. So a loop will not work if you use const. So by default, your starting value is probably going to be 0. That's just how it is. So we declare our value, we declare I, and we start it somewhere. Then we have a semicolon to say, okay, next condition. Condition 2 tells us how long to keep looping. At some point we need to stop. We will see in a minute what happens if we don't stop. So we need some sort of condition that tells us when to keep looping. This is going to be a Boolean. So this is usually some sort of comparison. In this case, I've said keep looping as long as I is less than 3. So let me put another note here. Run once at start. Condition 2 will be checked before every iteration. An iteration is just a time through. So like if you rode the roller coaster 5 times, you went on 5 iterations through the roller coaster. So this will be checked before every iteration. And if it's ever false, we're done. And then condition 3 is we have to change I in some way. And this is going to be run after every iteration. So in this case, we're saying I++. Remember I said plus plus would come and rear its ugly head? So what happens here is we start with condition 1, we create an I and set it to 0. Then we check condition 2, 0 is in fact less than 3, so we keep going. Then we'll run our code that's inside of the scope. So we print out 0. And then at the end, we increment I. I just increased up to 0. Then we do it all over again. So now we don't ever run our first condition again. We're going to increment it, check this, run it, increment it, check this, run it, etc. until this no longer is true. So because it's I is less than 3, we'll only run it a few times. And once it gets up to 3, then it will quit out of our loop. So these 3 conditions are the magic that lets our loop run. So let's explore what happens when things go wrong. Let's say that we said I minus minus. Instead of increasing I, we're decreasing it now. So we just had an infinite loop. Luckily, Replit will catch an infinite loop for you. So I kept decreasing. We got to about 5,000, negative 5,000. And then Replit was like, all right, we're done. So why did this loop never stop? That's because our condition for continuing is I is less than 3. If we keep decreasing I, it's always going to be less than 3. So make sure that everything's set up in a way where it's possible for your loop to stop, or else you'll have an infinite loop, which isn't the end of the world. Most of you will probably accidentally or on purpose write an infinite loop before the night is out. So another thing to make sure is that your condition can ever be true. So if this said I is greater than 3, it would never run. That's because the starting value for I is already false for the condition. If this value makes this condition false, your loop will never run. So yeah, that's another thing to keep in mind. So the next thing I want to mention is that you don't actually need, well, a note about I, which is that I should always be a number. So I is an index. It's meant to keep track of how far you are into the loop. You can sometimes, by default, you generally start it at 0, have it less than however many times you want to loop, and do ++. But you'll see some examples in the homework tonight where you get a little clever with it. But I should never be a string or anything like that, or a Boolean. That would create some chaos. I mean, I'm sure that you could set it up so it works, but definitely stick to I being a number. However, you don't necessarily have to use I in here. I is available within your loop scope, but you don't have to use it. For example, if you just wanted to log the word JavaScript 3 times, you could do that. Well, let me fix my condition. So that's totally valid. So I is available for use in your scope, and for most of the assignments tonight, you'll have to use it, but you don't need to. So these are the key takeaways. If you understand what each condition does and when it's run or checked, that's like the key to understanding looping. So, and you can look that all up online. That's all going to be available in documentation. So the last thing I want to show you is there are actually 2 keywords that are available within your for loop scope that can help you write even more sophisticated loops. Continue and break. So continue says, skip this iteration and go to the next one. Break says, quit out of the loop. So remember, an iteration is just a run through. So each time this runs, all the stuff in the loop scope runs, that is an iteration. So continue is going to be used when you want to skip one of the iterations but move on to the next one. Break is done when you just want to quit out of the loop. So let's start with something that counts up from 0 to 9. Oops. And make sure you put in the variable I, not the string I. So let's say that we hate the number 4. We just hate it, least favorite number. And we want to skip it. So we might say if I equals 4, nice little use of the triple equals, then continue. So this if statement is just saying, hey, if I is ever equal to 4, continue. That means skip this iteration, but continue the loop. So notice that now 4 is missing over here. If we hate 4 so much that we couldn't even bear to continue looping if 4 ever appeared, we could do break. Now the loop just quits once we hit 4. So this is kind of an alternative way of quitting out of our loop. By default, we'll quit out with this condition, but if we wanted to throw a new quit condition in or a second one in, you could always use a break statement. So continues and breaks aren't super critical. You'll have a couple chances to play with them on the homework, but they're good to know about and a good example of scope. Because if you try to use a continue outside of loop scope, you get an error. That's because it's only designed to be used within the scope of the loop. So that is everything I have for you guys tonight. Let me go over the homework and I will try to spend a little more time talking over it, and then I'll answer any more questions you guys have. Okay. First thing I want to say is that the result is spelled wrong in the example, and it like drives me insane every time I see it, but then I forget to fix it.